Hello everyone, welcome to Lenvis. This is Lenu. Hope you guys are doing well. In today's video, we are going to dive into types of chemical reactions from the chapter 1 Chemical Reactions and Equations from CBSE 10th Chemistry. Okay, so make sure you stay till the end of the video. You will get some amazing tips and tricks. Okay, and if you haven't subscribed our channel, please subscribe our channel and ring the bell icon, and you have to share this video to your friends also. Okay, yes, let's get started. Okay, what are the different types of chemical reaction? Actually, we have to study mainly 4 different types of reactions. Okay, yes, the first reaction is combination reaction. Combination reactions. So when you hear the word combination reaction, just think that there will be 2 or more reactants. Okay, 2 or more reactants will be there, and that will be converted to a single product. Only one product. Okay, like the word itself says combining. Something is combining together to form a single product. For example, A and B is combining together and you'll be getting AB. This is a combination reaction. Okay, and the second one is just opposite of this combination reaction, that is decomposition reaction. So what will be decomposition reaction? Yes, here there will be a single reactant. Okay, that single reactant is undergoing breakdown and we will be getting 2 or more products. A reactant cannot itself be broken, right? They cannot itself be. So what happens, you have to apply some energy here in the form of what? Some heat, yeah, light, or you have to pass some electricity. So the reactant will break down and it will form 2 or different product. Okay, yes. Then moving to the third reaction, that is displacement reaction. Displacement reaction. And what is displacement reaction? Here, the more reactive one will displace the less reactive one. So who is more powerful? When the powerful one comes, the less powerful one has to give the space to the more reactive one, right? That is happening in the case of displacement reaction. A simple example we will have look at, like imagine A is reacting with BC and A is more reactive than B. So what will happen? A will replace the position of B and B is kicked out. Okay, A is more reactive. A will kick out the B from its compound BC, and see, B is now alone, right? Okay, and the fourth reaction is double displacement reaction. So what is the double displacement reaction? Yes, fourth reaction we have to study double displacement. So in the case of double displacement reaction, imagine AB is there and CD is there, okay? And it happens the exchange of ions. Exchange of ions between the reactant. Okay, exchange of ions between the reactants. That is, you can see here, A will react with the D and B will react with the C. Like that, they will exchange their ions with each other. Okay, so we'll be getting double displacement reaction. Okay, yes, everything will be in reactant and product. Everything, all ions will be there, but there will be exchange. That is called as what? Double displacement reaction. So these are the main 4 different types of reactions we have to study. Now let us study in detail about combination reaction. As I told you, what is the definition of combination reaction? Single product will be obtained from what? 2 or more reactants. Single product will be obtained. Okay. Now let us discuss the examples for that. Yeah, this picture is clearly depicted in your textbook. You can see a beaker there, and what is inside the beaker? Yes, water is there and calcium oxide is there. So we are going to mix water and calcium oxide, and you must know calcium oxide is also called as quicklime. Another name of calcium oxide is quicklime. And what is happening during the reaction? Let us see. Calcium oxide reacts with the water, forming what? Calcium hydroxide. Okay, what is calcium hydroxide? CaOH twice. It is also called as what? Slaked lime. Calcium hydroxide. And when you touch the beaker, you will feel hot. That means during this reaction, heat energy is liberated. That is why the product side is written heat. Okay. So you can understand, it is clearly understand that here two reactants are combining and you will be getting only a single product. So this is an example for what? This is an example for combination reaction. Let us see another examples of combination reaction. That is, you can see burning of coal. What is coal, guys? What is coal? Coal is a form of carbon. Okay. So carbon reacts with oxygen. Burning means what? In the presence of oxygen, right? Carbon reacts with oxygen forming carbon dioxide. Okay. And water formation, you can see here. Formation of water from H2 and O2. Hydrogen and oxygen reacting together forming H2O. This is example for combination reactions. Hope you understand. Okay. Now we have to study the application of this one. The first reaction we discussed. Quicklime is reacting with the water forming slaked lime. Okay, let us discuss the application of this reaction. That is, a solution of slaked lime produced in the reaction is used for whitewashing walls. Have you ever observed whitewashing of the walls in your homes? If so, have you ever thought about what was the solution used for that purpose? Okay, as a science student or as a chemistry student, you must know what is that made up of. Okay, yes, whenever you see, now you will understand the concept, what is the solution that is made up of. Okay, so solution of slaked lime, okay, produced in the reaction is used for whitewashing the walls. Okay, and have you observed whitewashing walls become shiny after few days? Yes, right? Yes. So calcium hydroxide that is produced during whitewashing will react with the carbon dioxide in the atmosphere, forming calcium carbonate. That is why that is giving a shiny finish to the walls after 1 or 3 days. Okay, understand? So what is the product forming? The calcium carbonate that is giving shiny finish to the walls. Let us do the examples of this. Okay. Let us do some examples, questions related to this topic. Okay. Okay. First question is, what happens chemically when quicklime is added to water filled in a bucket? So we have seen this equation, right? This reaction, the first reaction or combination. Quicklime means calcium oxide. You have to know that what is quicklime, what is slaked lime. Okay, so what is forming during this reaction when quicklime is reacted to water? Yes, slaked lime is formed. And what is your observation? You will observe the evolution of heat and a hissing sound, right? Due to the formation of what? Calcium hydroxide. Okay, this is one question related to combination. Another question is, a solution of substance X is used for whitewashing. What is the substance X? So what is the substance that is used for whitewashing? Yeah, we have studied, right? Read the chemical reaction of X with water. Yes. What is X? X is quicklime. Quicklime reacts with the water forming calcium hydroxide that is used for the whitewashing walls. Okay, so X is calcium hydroxide and its reaction with the water you have to write. Okay, calcium hydroxide. That is, first of all, you have to understand quicklime, slaked lime. Okay, that points here. Very important. Okay, now you have seen that in this reaction of quicklime with water, heat is produced, right? Heat energy is liberated. So that type of reaction, we call it as exothermic reaction. So now as a subdivision, we have another reaction called exothermic reaction. What is the definition for exothermic reaction? Yes, what is that? Reactions in which heat is released. Okay, reactions in which heat is released. With the formation of along with the product, heat is also forming. That type of reaction we call it as what? Exothermic reaction. Okay, and you can see another examples that is from your textbook itself. Burning of natural gas. Okay, what is natural gas formula? You have to understand. Natural gas is nothing but it's methane. We will study this about methane detail in the next chapters. Okay, methane. Okay, CH4 formula note down. Burning means oxygen. Whenever carbon and hydrogen compound is burning in the presence of oxygen, you will be getting what? Carbon dioxide and water. Carbon dioxide and water are the products. Okay, you must balance this. Okay, we are already studied balancing in this equation. So whenever you write any equation from this chapter, you must balance it. Okay. Yes. Next is another example, second example for exothermic reaction. This is an example of respiration reaction. Okay. Glucose is, what is glucose? C6H12O6. That is glucose. It is reacting with oxygen. You will be getting carbon dioxide and water along with energy. You can see energy. So this is a what type of reaction? What type of reaction? Exothermic reaction. Also, the decomposition of vegetable matter into compost is also an example of what? Exothermic reaction. Vegetable matter into compost is also an example of exothermic reaction. So these are the three examples of exothermic reaction that is given in your textbook. Okay. Now let us move on to the next second type of reaction, that is decomposition reaction. Okay. In decomposition reaction, we have to study three different types of decomposition reaction. So let us move on to the first type of decomposition reaction, that is thermal decomposition. So I have already told that in decomposition reaction, what is happening? Single reactant, right? Single reactant is broken down into two or more products. So first you understand that single reactant breaking into what? Two or more products. Okay, and you can see the example here. What is taken in ferrous sulfate crystals? Okay, yes, and it is heating. You can see here it is heating. Ferrous sulfate crystals are heating. Okay, and what do you observe? There is some gas coming here. Okay, there is gas coming here. That is your observation. So you have to clearly understand this reaction. Very important. Almost all question paper contain this question of ferrous sulfate crystals. Actually, ferrous sulfate crystal was in the form of FeSO4.7H2O. Okay, it is green in color. Okay, green color, ferrous sulfate crystals, green color. When we heat that, this water will remove, and you will be getting FeSO4. Okay, and this FeSO4, when we are heating, right, it will be converted to what? Fe2O3, that is a solid, along with the evolution of SO2 and SO3 gases. Okay, this is the reaction you have to study. FeSO4. Okay, we have to heat that. This is ferrous sulfate. And what is Fe2O3? It is ferric oxide. Ferric oxide. Okay, and you must know the color change. I told you that ferrous sulfate crystals were initially green in color. When you heat that, you will be getting FeSO4, and green color loses and become a dirty white color. And at last you will be getting what? Ferric oxide, which is, what is the color of ferric oxide? Just note down, it is reddish brown color. Reddish brown color. Okay, along with the evolution of two gases, SO2 and SO3. So you will observe the color change from green green to what? Green to reddish brown. Also, you will observe the burning of sulfur smell. Okay, that characteristics odor of burning sulfur you have to observe here. Okay, burning of sulfur. This is the two observations that we see in these reactions. Okay, let us discuss the answers first. Oh, sorry, one question we have from this topic. Yes, see, what is the color of ferrous sulfate crystals? How does this color change from heating? Okay, name the products formed on strongly heating ferrous sulfate crystals. What type of chemical reaction occurs? What is the answer? Okay, all of you try the answer. See. FeSO4.7H2O crystals are green in color. They become dirty white on heating. And you'll be getting what? Ferric oxide. Okay, ferric oxide is a reddish brown solid in precipitate. And you'll be getting sulfur dioxide and sulfur trioxide. Don't forget to balance the equation. And this is a what type of reaction? Decomposition reaction, and decomposition reaction also this is a thermal decomposition reaction because you are providing heat in this reaction. Hope you understand. Okay, now again we have another reaction. What is this reaction? This is we are heating what? Lead nitrate. Okay, we have taken lead nitrate. We can see here lead nitrate. What is the formula of lead nitrate? PbNO3 twice. This is lead nitrate. We are heating lead nitrate, and what you are getting? You can see some gas are evolving, right? What is the gas? That gas is what? It is nitrogen dioxide. So you will be getting PbO, lead oxide, plus nitrogen dioxide and oxygen also during this reaction. So you have to balance this. Okay. Yes, putting a 2 here, balancing is completed. Okay. So this is another reaction we have to study. What is the observation? You will observe that nitrogen dioxide, brown fumes you will observe here. Okay. And what is the color of this PbO? What is the color of this PbO? Anybody knows? Yes, PbO is, so PbNO3 twice is what color? It is yellow color. Sorry, this is white in color. White. PbNO3 lead nitrate is what color? White color. We will write in another color. A white color which is turning to yellowish PbO. Yellowish. So these are the two observations we see in this reaction. Lead nitrate is simply heating. That is the thermal decomposition reaction is taking place. It is broken down into what all products? Lead oxide, nitrogen dioxide, along with the oxygen. And nitrogen dioxide is seen as brown fumes. And the color change is from white to what? Yellowish color of lead oxide. Okay, clear? Hope you understood, right? Yes. Okay, moving to the next question we will discuss. Okay, next is what? This is the second type of decomposition reaction, that is electrolysis. So last year from these questions were asked. Okay, CBSE board exams. So let us discuss in detail what is happening. You can see here water. Yes, water. So we are doing water electrolysis we are doing. H2O gives H2 plus O2. Okay, what is the reaction? So we are taking water, you will be getting H2O and oxygen as the products. Okay, and during electrolysis, we have to arrange anode and cathode, right? Yes. So what is anode? Here you can see anode here, okay? Anode here and cathode here. And what is the product that is formed in the anode? Yeah, it is oxygen, right? Anode, oxygen is formed. So you have to study that. In anode, which product? Oxygen. And in cathode, what? Cathode, it is hydrogen. Okay, so must know first that which gas will be evolved in which electrode. Okay, understood. Then what is happening to the next? Next, you have to see what is the ratio of hydrogen and oxygen. Okay, we can see hydrogen and oxygen ratio as 2:1 ratio of hydrogen and oxygen. That is also very important. Last year, the question was, this is the volume, ratio of the volume. Okay, volume ratio of hydrogen is to oxygen. Last year, it was asked the ratio of masses. Ratio of masses of hydrogen and oxygen. Okay, hydrogen and oxygen. So you must know how to find out the ratio of the masses. So let us take the mass of hydrogen is equal to 1 and oxygen is equal to 16, right? How many hydrogen atom? 4 hydrogen atom. 4 is the mass of hydrogen. Oxygen is 32. 16 plus 16, 32. And you will be getting 1:8 as the ratio of masses. Why I am specifying this? Last year, the same question is asked as the multiple choice MCQ. Okay, it was the first question in some set. Okay, set paper. So, so students who were not aware of the mass and volume difference all made incorrect this question, because mass means this one. 1:2, and volume ratio you are asked hydrogen to oxygen 2:1. If you are asked oxygen to hydrogen, you have to interchange the ratios. Okay, otherwise you will go wrong. Okay, everything will be in the option 1:2, 2:1, like that. Okay, yes, this is the things you have to keep in your mind about electrolysis of water. Okay, now let us see some examples of here. Examples, okay, related to some examples here. You have to name the gas collected at cathode and anode. Simply from the picture, you will be getting the idea which gas is collected at cathode. Cathode, hydrogen gas at cathode, and oxygen is at anode. Okay, so I will give you some clue to study that you will always remember. We know anode, and anode. So in anode, which gas? Oxygen gas. So automatically in cathode, which gas? Hydrogen gas. So anode. Specify this word anode for of anode and understand in anode oxygen. Okay. Yes. It is why is the volume of gas collected at one electrode double than that of the other? Because we know that water contains hydrogen and oxygen in the ratio what? 2:1 ratio. I already mentioned, right? Yes. Then how will you test the presence of hydrogen gas? Yes, you have to bring a burning candle or matchstick near to the gas of coming hydrogen. Okay. If the gas burns with a pop sound, the gas is hydrogen gas. So you will study this same in the next chapter, acid, bases and salt. How will you test the presence of hydrogen gas? Okay. So bring a burning candle, a matchstick near the gas. If the gas burns with a pop sound, then the gas is what? Hydrogen. Okay. Hope you understand. Okay, now moving to the third type of decomposition, that is photochemical decomposition. Photochemical decomposition takes place in the presence of what? Light. You can see here in the China dish there is something. What is that? Yes, it is silver chloride. It is given. Then what is the formula? Silver Ag chloride Cl, AgCl, and it was white in color. And you can see here when the presence of sunlight, this silver chloride is turned into silver gray color. Gray color silver and chlorine gas. Okay, so this is a photochemical decomposition reaction. Like this, You can see here name two salt that are used in black and white photography. So this is the application of this reaction. Okay, silver bromide, the silver iodide are used in black and white photography. When they react with the sunlight, you will be getting what? Silver solid. AgCl also. Okay, AgCl, AgBr, AgI. All these are used in the application of what? Black and white photography. Hope you get the clear information about the photochemical decomposition reaction. Okay. Yes. Now we have to move to the third one, displacement reaction. So what is actually displacement reaction? So let us understand the definition. More reactive one will displace the less reactive one. More reactive one will displace the less reactive one in the displacement reaction. So you can see the picture that is given in your textbook, the very simple. Sometimes this picture will be given in your question paper also, and you will have to write down the observation. So this was the initial stage. It was iron and copper sulfate. Let us write down iron. This is Fe, and copper sulfate is CuSO4. Iron and copper sulfate. So what was the observation? You will see that the copper sulfate was initially blue in color, right? Yeah, it was blue in color. And what happens now? The blue color is faded. What is the observation? In the test tube B, you can see, in the test tube B, you can see the reaction mixture, blue color fades. Color is faded. And what is happening to the iron nail? Iron nail, what happened? It becomes a reddish brown coating on that. Okay. And you will observe reddish brown coating in iron nails. These are the two observations you will see here. And what is happening? Iron is more reactive than copper. So it will kick out copper from its copper sulfate solution, and you will be getting FeSO4 plus Cu, copper. So which is more reactive? Iron. So that will kick out the other one, and it will takes the place of that. So that is called as, this reaction is displacement reaction. Understood? Okay. Okay. Do this next question. A zinc plate was put into a solution of copper sulfate kept in a glass container. It was found that blue color of the solution gets faded with the passage of time. After few days, when zinc plate was taken out, number of holes were observed on it. Okay, what is the reason? Yes, reason is very simple. Zinc is more reactive. So zinc is displaced copper from copper sulfate solution, and you will be getting zinc sulfate and copper. Okay, that is zinc gets consumed due to which holes are formed in zinc plate. Okay, zinc displacer copper from copper sulfate solution, so that copper sulfate blue color faded, and also zinc gets consumed. That is why we can see the holes on the plates. Another question: when a metal X is added to salt solution of Y, the following reaction takes place. Mention the inference you draw regarding the reactivity of metal X and Y, and also the type of reaction. State the reason for your conclusion. Okay, so you can see metal X and solution of Y, and what are the product? Solution of X and metal Y. So metal Y is kicking metal Y out, right? So what is happening? X is more reactive, so that is why it kick out that Y. Okay, X displaces Y from its salt solution. Hence, this reaction is an example of what? Displacement reaction. Okay, now moving to the fourth reaction, double displacement reaction. Double displacement, what I told you, exchange of ions between the reactants. Exchange of ions between the reactants takes place. Okay, now let us see here. What is taken? Barium chloride. Okay, barium chloride. We have taken barium chloride. BaCl2. And what is the next one? We are going to mix sodium sulfate. What is the formula? Na2SO4, sodium sulfate. And you will be getting a white precipitate of BaSO4. And these two are combining, and these two are you have to combine along with 2NaCl, sodium chloride and barium sulfate are the product forming in this reaction. Here you can see what exchange of ions between the two reactants. That is why this is called as what? Double displacement reaction, and you will observe here a white precipitate. And you have to understand what is precipitation. Precipitate means it is a insoluble solid that is formed in this reaction. That is here during double displacement reaction always white precipitate is forming. So we call this reaction another name, that is precipitation reaction. Understood? So this is the double displacement reaction, very important reaction. Okay. Another example you have studied in the first part of this was, I will show you. Yes. You have mixed lead nitrate and potassium iodide. Let us mix that. PB nitrate, NO3 twice, and potassium iodide, Ki. You will be getting what? Just exchange of ions will take place. You will be getting PbI2 plus KNO3. So this is a double displacement reaction. What is the color of the precipitate? Very important question. The precipitate color is yellow. Yellow color precipitate. And what is the precipitate? Is lead iodide. So we are taking the solution. So you have to mark like aqueous, and this is the solid substance, that is yellow color substance that is forming. So this is again aqueous, and don't forget to balance the equation. Okay, write the balanced chemical equation. Is this also double displacement? Of course, this is also a double displacement reaction. Okay, another question you can see here. Yeah, same answer, yes. And what is observed when a solution of potassium iodide is added to a solution of lead nitrate? What is observed? You observe a yellow precipitate, right? And what is the yellow precipitate? Lead iodide, PbI2. And what is this reaction also called as? Double displacement and precipitation reaction. And write the balance equation. Clear? Yes. Another question you can see here. A solution of potassium chloride when mixed, potassium chloride mixed with AgNO3, silver nitrate, you will get an insoluble white substance. Write the chemical equation, mention the type. So AgNO3, KCl. Just interchange, you will be getting AgCl and KNO3. Then AgCl will be that white precipitate. What type of reaction? Exchange of ions takes place. So this is a double displacement reaction. Understood? Yes. Now, these are the main four types of reactions we discussed: combination, decomposition. In the decomposition itself, we have discussed about what thermal, electrolysis, and photochemical decomposition. And we have studied displacement and double displacement reaction. And another one important we have to study is oxidation and reduction. Okay. So, first of all, you must understand what is oxidation. Oxidation is addition of oxygen. When you are adding oxygen, it is called as oxidation. Okay. And what is reduction? Reduction is just opposite of oxidation. If you are adding oxygen, that is oxidation. You have to remove oxygen, that is what? Reduction. Removal of oxygen. Okay. Again, this is in terms of oxygen. So what will be in terms of hydrogen? So reduction is addition of hydrogen. So what will be oxidation in terms of hydrogen? Removal of hydrogen. Just opposite is the concept. Okay. Now let us come into this reaction here. CuO, copper oxide, right? Copper oxide is having a copper oxygen in it, and we are getting Cu. That means we are added a hydrogen to that, and this oxygen is removed from the copper, right? Removal of oxygen is what? Reduction. So copper oxide to copper is reduction process, and to this hydrogen oxygen is added, so that is oxidation. Clear? Okay, now see here, you have to understand two other terms, that is oxidizing agent and reducing agent. Oxidizing agent and reducing agent. Very important. Just to understand one, you will get the other very easily. So oxidation is addition of oxygen. Who is undergoing oxidation here? Hydrogen, right? This is undergoing oxidation. So this is undergoing oxidation means hydrogen is the reducing agent. Okay, just opposite. Who is undergoing oxidation? That is the reducing agent. So copper oxide is undergoing reduction, right? So who is the oxidizing agent here? This one. This is the oxidizing agent. Just opposite. Who is undergoing oxidation? Oxidation, reducing agent, reduction, oxidizing agent. Just opposite. So who is oxidizing agent? The one undergoing reduction. Yes. And who is the reducing agent here? The one undergoing oxidation. Just the reverse. Okay. Don't feel confused when studying this. We have to understand the concept very clearly. Sure questions will be coming from this topic of oxidizing and reducing agents. Hope you understand. Okay. Any doubt you can ask me. You can comment. Okay. I will help you with your doubts. Okay. Don't worry. Okay. Now you have to study about corrosion. So we have you heard about corrosion? That is our cycle parts, etc., becoming reddish brown, that chain of that, right? So when iron articles, they will when we buy that, it is very shiny, but after some time, after you can see reddish brown powder, right? So that is generally called corrosion. Okay. So in the case of iron, we call it as another name. What is that? Rusting of iron. So what is happening here? Corrosion. This is copper corrosion. Copper's corrosion is due to carbon dioxide, and you will be getting what? Basic copper oxide. Basic copper carbonate. This is the formula of this green coating. Okay, green color coating on copper particles due to the carbon dioxide. And this is silver articles. Silver corrosion is due to what? Sulfur present. Sulfur. And what is the product forming? Silver sulfide. Silver sulfide. Okay. I'll write it again. And what is silver corrosion is due to? It is due to sulfur, and you will be getting silver sulfide. And one more thing, what is this color of silver sulfide? You will get a black coating. Okay, black coating. Okay, now this is what? Rust. Rust is Fe2O3.XH2O. This is rust. Okay. And what is this? Rust is due to the presence of water content. Yeah, moisture and oxygen present in the atmosphere. Okay. That is the reason for rust. Okay. Then copper corrosion, silver corrosion, and rust you have to understand. And how will you prevent this? You can prevent this corrosion by oiling, coating, painting, greasing, or other methods like electroplating. You can use anti-rust solutions, tinning, or galvanization. All these methods you can employ to prevent from rusting or corrosion. Okay. Then one more topic you have to discuss in this chapter is rancidity You will have observed some food items becoming rancid. That means when left for long time, yes, we will experience some foul smells or there is a change in the taste of them. So what is it due to? It's due to this rancid because of its oxidation. Okay, how will you prevent the oxidation of the food items? You have to keep the food items in low temperature. That is, you have to keep them in the refrigerators. Okay, now you can keep the food items in airtight containers, or you can oiling it. You can add preservatives, like we are adding preservatives while making pickles, right? Not to not become rancid. So all these things you can employ. Okay, so we are now on to balancing chemical equation. Okay, so why we are balancing chemical equation? Okay, why? Yes. So we must know a law of conservation of mass. Okay. So in order to obey, which law? Which law? Law of conservation of mass. Conservation of mass. We are doing balancing. Okay. That means we have reactant side. Okay, and we know that reactants are converted to products in a chemical reaction, right? Okay, so you know that these reactants and products, they should have equal mass. Okay, then only they will obey the law of conservation of mass. So in order to balance a reaction, we must know how many reactants and products each side. Okay, so let us get started. From the simple one, we are going to start first. Before that, yeah, I want you guys to understand certain concepts before doing balancing. That is, for some elements, okay, some elements like, which are that some elements like hydrogen, oxygen, nitrogen, okay, fluorine, chlorine, iodine, this is chlorine, bromine, okay. And these elements are diatomic. Okay, these are what? Diatomic. So they cannot exist alone. They exist always as a molecule by combining two atoms of that. Okay, by doing covalent bonding, they are doing so. Okay, so this is diatomic. So whenever you see hydrogen or oxygen or nitrogen alone, you have to write it as H2, N2, O2 like that. Okay, then only the balancing, the first thing you must know this. Okay, H2O2, N2, then halogen family F2I2, chlorine and bromine. Okay, that is the first thing you must understand before balance. And the next thing you have to understand, you must know some charges or some ions. Like first of all, you should know positive ions, positive ions. Important one we have to know. We have to study that by heart. Okay, automatically you will study after doing, while doing balancing, it will automatically you will store that all things in your mind. Okay, like hydrogen ion H plus, sodium, okay, lithium, potassium. These are plus one ions, only plus one charge. So because we know they are group one elements, they readily lose their electron. Whenever an element loses electron, they will get which charge? Positive charge. And you have to know plus two ions, calcium ions, okay, barium, Ca2 plus, zinc, magnesium. Okay, these are all positive ions, positive 2, okay, plus 2 charge. And what is the next one? 3 plus, that is Al. Al is 3 plus, and lead is Pb 2 plus. And iron can be Fe2 plus or it can be Fe3 plus. It will be given Fe, like Roman letter in bracket, it will be given which one you have to choose here. Okay, these things you must remember at least. Okay, at least these you have to keep in your mind. And negative ions you have to study, right? For negative ions, what are the first negative ions? Like chlorine, bromine, iodine, fluorine. Okay, that family. So fluorine F minus, chlorine what? Chlorine Cl minus, bromide ion Br minus, then iodide I minus. Okay. Then after that you must know two minus ions like oxide ion O2 minus. Okay. Then nitride ion you must know N3 minus. It is 3 minus. Sulfide is 2 minus. Okay. Hydroxide, very modern. OH minus hydroxide. It is a polyatomic ion. And some polyatomic ions also you have to study. That is sulfate. SO4 2 minus. Sulfate. Carbonate. CO3 2 minus. Then nitrate is NO3 minus. NO3 minus. Then phosphate is PO4 3 minus. Okay. At least these ones you have to keep in your mind. Okay. So it will help you in balancing. I'm definitely sure about it. Okay. So first of all, you just revise it every day. It will automatically store in your mind. So balancing will become easy. When you are able to write down the formula, only balancing will be easy. Otherwise, you will struggle in balance. Okay. So first of all, I am going to help you with formula making. Okay. For example, I will we can start balancing. Okay. Balancing equation. Okay. While balancing, what you have to do is, it is given first reaction in your textbook. Magnesium reacts with oxygen. Okay. Magnesium and plus oxygen. It is giving forming what? Magnesium oxide. Magnesium oxide. So first of all, it is given in words, right? First you have to convert it into symbol equation. Okay, right, symbol equation. How will you convert this into symbol equation? Okay, this is word equation, guys. Word equation, because it is given in words, right? Yes, this is given in words, so this is called as what? Word equation. And for next, you have to convert it to symbol. What is the symbol for magnesium? It is Mg, right? It is given here. Magnesium is Mg, the symbol. Magnesium is sitting alone, so there is no charge here. So Mg plus oxygen. I told you that whenever oxygen is sitting alone, it is sitting, right, alone. So what you have to do? You have to put a, how? It is a diatomic, right? So O2 you have to write. O2, okay? Yes. So oxygen is O2 and put the arrow. Next is magnesium oxide. Okay, how will you write magnesium oxide formula? And there you have to take that charges, okay? Because it is a compound magnesium oxide and we know magnesium is 2 plus charge and oxygen is 2 minus charge, right? Yes. So you have to crisscross rule you have to apply here, okay? Yes. So you'll be getting what? Mg. This 2 will come here to O2. So this is Mg to O2. That means same charge, same numbers, right? So we can simplify it as MgO. So this is magnesium oxide. You can write here magnesium oxide. Okay. Yes. So the next, what is the next step? Just you go through both reactant side and product side. Is the number of reactants and products are same? Magnesium is 1. Okay, it is 1. And here also it is 1. Okay, fine. What about oxygen? Oxygen here 2. There are 2 oxygen atom, right? And here only 1 oxygen atom. So automatically what you have to do? What you have to do? You have to make it 2, right? Where is 2? Here 2, here only 1. So you have to make it 2 in the right side. What do you have to do? Just think, can you put a 2 here? MgO2. Can you put that? No, definitely no, right? Why? Because when you put here MgO2, magnesium oxide formula we have already found it is MgO only. If you put a 2, it becomes another one that is not existing, right? So you cannot put a 2 here. So instead you have to put a 2 word in this side only, 2. Okay. Here you have to write down the symbol, a number. Okay, 2. So automatically now oxygen 2 here, 2 here. But this 2 is for magnesium also, right? It is common for both magnesium and oxygen. So magnesium here become 2. So in this side only 1. Can you put a 2 here to make it 2? No, no. So what you have to do? Because magnesium is not a diatomic like oxygen, right? So we cannot do that. And what you are going to do now? You have to put a 2 here. So you will be getting what? Mg. 2 mg plus O2 gives 2 MgO as the what balanced equation. So before balancing, we write the word equation, right? So this is actually which equation? Word equation. Okay. Yes. Now we have already written one equation like this, right? Mg plus O2 giving MgO. And this equation we call it as what? Skeletal equation. Okay. What equation is that? Skeletal equation. And last we are getting which equation? Balanced equation. Okay, balanced chemical equation. So this is the method. And you can draw table like reactants, products, elements like that, number counting. But after you are thorough with balancing, no need of any table. Okay, you will automatically, when you see equation, you can automatically do that. Okay, we will try another question. Okay, for example, it is given lead nitrate. Okay, lead nitrate and potassium iodide. And you will be getting the product as lead iodide and potassium nitrate. So this is a what equation? Word equation. Word equation. Equation is given in words. First of all, you have to write down the formula, chemical formula of all these compounds. Then only you can balance, right? So what is lead nitrate? Okay, let us try. Lead is Pb2 plus, right? Okay, I have written that. Nitrate. Nitrate is NO3 minus. Okay, minus means minus 1. Okay. Now, for forming lead nitrate formula, you have to crisscross this, right? 1 to this side, you will be getting Pb1. So, this is a polyatomic ion and this 2 is common to nitrogen and oxygen. You have to put in brackets, okay? NO3 twice. PbNO3 twice. That is lead nitrate, okay? Then what is potassium iodide? Potassium is K plus 1. Iodide is I minus 1. So crisscrossing, you will be getting what? Ki, potassium iodide. Okay. And then arrow mark. What is lead iodide? Lead is Pb2 plus. Okay. And iodine is I minus 1. Crisscross. You'll be getting what? PbI2. Lead iodide. Okay. And the next is potassium nitrate. Okay, potassium nitrate means what? K plus 1. Nitrate is NO3 minus 1. So both are 1, right? So you'll be getting KNO3. Okay, right? Yes. Okay, hope you understand how to write down the formula and convert it into which equation is this? Yes, this is skeletal equation. So we have reached skeletal equation now. And the next task is we have to balance what? We have to balance, yes, say this equation, right? Okay. First of all, we have to do what? Which element we will take for first, which is easy to balance? That is the first question we have to go through. So see, whenever you see polyatomic ions, first you try to balance that, okay? After that, you have to take metals and then non-metals, okay? Then comes you try hydrogen, okay? And lastly, you try only oxygen, okay? So this is a stepwise you have to try. Polyatomic ions, if you see any polyatomic ions, just balance that first, okay? Then take metals, then any non-metal if present, that one. After hydrogen and only last take oxygen, okay? Yes. Moving back to this question. Okay, yes, here it is polyatomic ions present, right? NO3 is present here, 2. NO3 polyatomic ions is 2 here. And what about this side? NO3 here it is 1. How will you make it 2? Yes, you have to put a 2 here, right? So that will be balanced, right? Clear? Okay, now see. What is the next? You have to take any metals. If there is any metals, you can take that. Yes, there is one metal PB. Okay, and here PB is 1. Here also PB is 1. So put it there. And you have to take another metal here, potassium K. Here 1K. Yeah, here 2K is there. So make it 2 here in this side, putting a 2 here. Okay. Then what is the next element? Next iodine. Check iodine. Here are 2 I. Here I 2. Okay, iodine is balanced. Now everything is balanced, right? So this is the balanced chemical equation now. Hope you're understanding, right? Understand? Yes. Okay, very good. Moving to the next question. So this you have to keep in your mind. Okay. Next, take the another example. Zinc reacts with sulfuric acid, giving zinc sulfate plus hydrogen. Okay. What is zinc? Zn. It is same, just monoatomic. So write Zn. Sulfuric acid. What is the formula? Sulfuric acid. Okay, if you don't know the formula, you have to study the acid's name. Okay, you have to study some acid's name. How will you study that acid's name? Like H2SO4, that is sulfuric acid. HCl, that is hydrochloric acid. HNO3, that is nitric acid. Then H2CO3, that is carbonic acid. And one more thing you study, CH3COOH, that is acetic acid. Okay, so these are the acids names. Okay, you have to practice this by hearting. Okay, so it will be helpful if you are struggling with by hearting the acids name, acids formula. What is sulfuric acid? Acid containing H plus, right? So H plus. Sulfuric acid containing sulfate. So SO4 2 minus. So you'll be getting what? H2SO4. Understand how it is coming? H2SO4. Arrow mark. Zinc sulfate. Zn2 plus. Sulfate is SO4 2 minus. So yes, same, right? ZnSO4 plus hydrogen. It is hydrogen is existing alone here. So it is diatomic. Put H2. Otherwise, whole equation you will go wrong. Okay, now you get the skeletal equation, right? Now try balancing. Balance the polyatomic ions present. SO4, that is already balanced. Only one, right? On both sides. Then take zinc. Yes, zinc is only one. Correct? Right. Then take H2, H2. So this is also a balanced chemical equation. Okay. Skeletal equation is same as balanced chemical equation. Hope you understand, right? Yes. Moving to the next question. Fe. Now you are given the equations. Okay. H2O giving Fe3O4 plus H2. Okay, so see, in this equation, let us take what are the elements present here. Iron is here, hydrogen is here, oxygen is here. So we can start with the metal, right? Yes, we can start with the metal, which is the metal here. Iron is the metal. So iron is 1 here, 3 here. So put a 3 on the left side. So now iron is balanced, right? Okay, now what you have to do? What is the next step? Next, you have to take hydrogen. Okay, hydrogen is now 2 and 2. It is already in a balanced state. So put it there. Take oxygen. Oxygen here it is 1. Here it is 4. Okay. So what you have to do? Oxygen, you have to make it 4 in this side. Okay. So you have to write a 4 here. So 4 oxygen it will become, right? Clear? Yes, for oxygen. Now what you have to do, understand here, oxygen is now balanced, but hydrogen number is turned to 4 times to 8 here, and here only 2, right? So how will you make it 8 here? You have to write a 4 here. That is the next step. Clear? So we will be getting 3Fe plus 4H2O gives Fe3O4 plus 4H2. So this is the balanced chemical equation for this. Okay. Hope you are getting how to balance that, right? It is very simple if you understand the concept. Okay. So first of all, you have to study what are the diatomics one. Okay. And what are the ions charge that you have studied in the ninth standard. Okay. So you have to by heart that. You have to revise it. Keep revising every day. Take 2-3 minutes to revise it. So automatically after a few days, automatically everything will be thorough in your brain. Okay. Don't worry. Okay. Do the next one. It is given hydrogen combines with nitrogen, giving ammonia. Okay. So hydrogen is sitting in a halon. So put H2. Nitrogen is also diatomic, N2. And what is the formula for ammonia? You have to study the formula for ammonia is NH3. Okay. That is NH3. So the formula we get, and now it's time to balance that. Okay. Now see, nitrogen here, hydrogen 2 and 3. Okay, 2 and 3. Very interesting, right? One even number and one odd number. So what you have to do, whenever you see one odd number and 2, 3 like that odd and even numbers, take the common factor of that. In 2 and 3 table, what is common? 6 is common, right? So you have to make it 6. In order to make this side 6, you have to multiply with this 3. Just opposite. Okay. In order to make it here 6, you have to multiply it with 2. Okay. So automatically nitrogen is also balanced now, right? So this is the again next trick. Okay. Whenever you see 2 and 3 like odd and even number, okay, you have to take the common factor of that 2 and 3 table. That is 6. You have to make both sides that common. Okay, like that. This is good. Okay. Yes, moving to the next question. BaCl2 plus H2SO4 gives BaSO4 plus HCl. Okay, see this question. Sulfate. Take the polyatomic ions. It is balanced. Okay, don't do anything. Take the barium. That is the metal. It is also balanced state. Okay, now you take chlorine. Chlorine is only 1 in this side, only 2 in this side. So make it 2 by adding it 2 here, right? So automatically hydrogen here 2, here already balanced. Hope you understand. I'm going little bit fast. You have to come along with me, okay? Next is NaOH plus AgNO3 giving AgCl plus NaNO3. Okay, fine. What do you have to do? Now take the polyatomic ion here 1, here 1. Okay. No issues, right? Okay, take the metal Na. Okay, again no issues. Ag. Okay, wait. Just a second. Okay, this is not NaOH, guys. NaCl, NaCl. Okay, this is NaCl. I thought that in one side there is Cl and next side there is, okay, yeah. So this is NaCl. Okay, yeah. NaCl plus AgNO3 gives AgCl plus NaNO3. Okay, Na is 1 1, Ag is 1 1, Cl is 1 1. Okay, already this is a balanced chemical equation. Another one, NaOH plus H2SO4 gives Na2SO4 plus H2O. Try balancing. Okay, try the polyatomic ion. That is okay for here. Try the metal Na. It is 2 here, only 1 here. Put it 2 here. Okay, now what happened? Try hydrogen. Hydrogen here. Yeah, hydrogen is having some issues here. 2 here, 2 here. So 4 hydrogen, right? In this side, 2 and 2, 4 hydrogen. So put it 2 here. Now check oxygen. 2 oxygen atom, right? Now it is balanced. Okay. Yes, next question is potassium, potassium bromide plus barium iodide gives potassium iodide plus barium bromide. Okay, all of you try balancing this. Potassium bromide, KBr. Barium iodide, Bai2. Barium is 2 plus, iodine 1 minus. So Ki plus Br2. Potassium is K is balanced. Okay, Br here 2, right? So you have to put a 2 here. And Ki I2, put a 2 here. Now check. Balanced, right? Yes, this is balanced chemical equation. So this is the method you are doing. Okay, actually you have to start from the polyatomic ion if any present, and you have to go through the metals, then non-metals, then hydrogen. At last only you please try what? This oxygen. Okay. Yes, one more important thing we will discuss, very important. PbNO3 twice, potassium nitrate, you will be getting PbO plus NO2 plus oxygen. Okay, so this is very just complicated, right? Because NO3 here polyatomic ions, but in this right side it is not just sitting as NO3, so we cannot balance as NO3, right? So it takes time. So just take nitrogen. How will you balance this nitrogen? Lead here only 1, here only 1. Okay, now nitrogen here 2, you can see, oxygen 6. So in these type of questions whenever comes, so you just write down what are the elements given and write down right hand side and left hand side. Okay, in the right side you can see Pb1, this is right side, this is left side. Okay, okay, 1 and nitrogen here 1 and oxygen 1 2 3 4 5. Okay, yes, and in the case of left side 1 2 here nitrogen, oxygen 6. So it is very easy to balance this nitrogen, right? So put a 2 here, let us see, put a 2 here. So nitrogen becomes balanced, but in the right side oxygen is now turned into 2 times 2 4 5 6 7. Okay, it is now changed to what? Changed to Okay, 7 and 6 and 7, right? An odd number versus an even number, right? So it is very difficult to balance. What you have to do? So where is 7? In the right side it is 7. So in the left side it is 6 only. Small number is in here. So you have to multiply throughout here, throughout with the small. First small number is, after 1 we have to do 2, right? So automatically again everything is changed in left hand side. PB becomes 2 now. Nitrogen now becomes 2 times 2, 4. Okay. Oxygen now becomes 6 times 2, 12 in the left side, right? Okay. Now just try balancing. Try balancing PB. It is now what? It is now 2. Okay. So it becomes 2 here. So PB is balanced. Try nitrogen. It is 4 here. You have to put a 4 here instead of that. Instead of what? These 2. Okay. Now what you have to do? Oxygen. Check the number. Oxygen in here it is 12 in the left side. Right side 2. 2 times 8 times 2, 10, 12. Automatically 12. So that is balance. So this is the method you have to employ here. First you put simplest one, you try balancing. After trying balancing, if you are not getting, just multiply very small number throughout that by the small numbers. Like after 1, the next number is 2. You have to try 2 there. Okay, if 2 is working, try the 2 will work. Okay, yes. So this is the method of balancing chemical reactions. Okay, hope you enjoyed the video, right? If you find the video is useful to you, please make sure you share it with your friends. Okay, yes, and don't forget to hit the subscribe button and ring the bell icon. Okay, and please put your valuable comments in the comment box. I would love to hear from you guys. Okay, okay, then see you in the next video. Till then, stay curious, keep learning. Bye.